One particular piece of the quadratic formula can give us a lot of information about the solutions to an equation. If we look at the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This chunk that sits underneath the radical sign, the b squared minus 4ac, is called the discriminant. Just the b squared minus 4ac. Not the square root sign that's over all of it, but just the stuff that's highlighted in red there is the discriminant. You can tell a lot about the graph and the solutions of a quadratic equation just by looking at that one little piece of the quadratic formula, just by looking at the discriminant. Let's take a look at what happens when the discriminant is positive. Here's the equation we worked with in the previous section. Y equals negative 4z squared plus 7z plus 5. If we were to set up the quadratic formula to solve this equation, here's what it would look like. We plugged in 7 for b, negative 4 for a, and 5 for c. Let's focus just on the discriminant, just on this chunk underneath the radical sign. 7 squared minus 4 times negative 4 times 5. If I focus just on that part alone, I notice that it's simplified to 129. In this case, the discriminant was positive, and I ended up with two separate solutions to the equation. I had the negative 7 plus the square root of 129 over negative 8, and the negative 7 minus the square root of 129 over negative 8. I ended up with two separate solutions. It is always true that when the discriminant is positive, there are two solutions to the equation, and the parabola crosses the x-axis in two places. When the discriminant of an equation using the quadratic formula is 0, you'll end up with a graph that's like the one shown at the right here. This is the graph of y equals x squared minus 12x plus 36. Let's go through and work the quadratic formula for this equation and see how the discriminant turns out to be 0. So let's say that I wanted to solve this equation. 0 equals x squared minus 12x plus 36. If I use the quadratic formula to solve it, I plug in 1 for a, negative 12 for b, and 36 for c. I'm going to focus just on the discriminant. That's the stuff underneath the radical sign here. When I simplify that stuff, the discriminant becomes 144 minus 144, or 0. If you think about it, the square root of 0 is just 0, because 0 times itself is equal to 0. And 12 plus 0 divided by 2 gives me the same thing as 12 minus 0 divided by 2. Both the plus and the minus equations here will result in the same solution. That is the one single solution. In this case, it's 6, 0. That's the point where the parabola just touches the x-axis. The vertex of the parabola is right on the x-axis. When the discriminant is 0, you have exactly one solution, and the parabola touches the x-axis at its vertex. What about when the discriminant is negative? Shown here is the graph of the equation y equals 2x squared plus 6x plus 5. If I were to try and find the solutions of this equation using the quadratic formula, here's what would happen. I would set the equation equal to 0, and then I would plug in a, b, and c into the quadratic formula. Let's focus in on the discriminant now. When I do that, the stuff under the radical sign simplifies into 36 minus 40, or negative 4. This asks the question, what is the square root then of negative 4? What number times itself gives me negative 4? There is no real number that meets that criteria, because no matter what, when you multiply a number by itself, your answer is going to be positive. When the discriminant is negative, there are no solutions to the equation, and the parabola does not touch or cross the x-axis. If you look at the graph above, you'll see that there is no point on that blue parabola that has a y-coordinate of 0. It might help you to put this table into your notes. This is in your textbook in section 10.7 as well. If the discriminant, that is b squared minus 4ac, is greater than 0, if it's positive, you have two solutions to the equation, and the graph crosses the x-axis in two places. If the discriminant, b squared minus 4ac, is equal to 0, you have one solution, and the vertex of the parabola just touches the x-axis. If the discriminant is less than 0, if it's negative, then there are no solutions because the parabola never crosses the x-axis.